Hi, so this is the second video in my series on the modulus argument form of complex numbers. So we're going to express this complex number z, 2 plus 2i, and we saw in the previous video that this is modulus argument form of a complex number. So we need to work out the radius, and we can work out r by using an Argand diagram. So if we have the imaginary axis, which we know is the y-axis, and the real axis, where we can plot 2 plus 2i as 2 real parts and 2 imaginary parts. So this will have coordinates 2 and 2. And we can show the complex number coming from the origin. So now we need to work out the radius. So the radius will be the magnitude of this complex number. And we can work this out using Pythagoras' theorem. So this will be the magnitude of z, which we know is the radius. This will be the square root of 2 squared plus 2 squared. So the square root of 4 plus 4, this will be the square root of 8, which simplifies to make 2 root 2. And to work out the argument of z, well, this will be theta, so the angle going anti-clockwise from a real axis. So the tan of theta will be the opposite, which is 2, over the adjacent, which is also 2. So this will be theta is the arctan of 1. So theta will be pi over 4. So in modulus argument form, z will be the radius, 2 root 2, multiplied by the cos of the angle pi over 4, plus I sine of that same angle, of the argument pi over 4. Okay, so this is the modulus argument form of this complex number. So perhaps you want to try and work out the modulus argument form of a complex number in question B. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we'll do is we'll plot this on our Argand diagram. We know it's got a real part of -1, so somewhere around here, and an imaginary part of root 3, so call that about here. So this will be our complex number on the Argand diagram, with coordinates -1 and root 3. Okay, so the first thing is to work out this radius. So the radius will be the magnitude of a complex number. And we can work this out using Pythagoras' theorem. This will be 1 squared plus root 3 squared. So 1 plus 3. So this will be root 4. The radius will be 2. But now to work out the argument, well, the argument has to go from a real axis. So this will be the argument of z. And we'll call this theta. But we can work out this theta by working out this angle, which I'll call alpha. I'm working out this one because this is part of a right angle triangle here. So to work out alpha, we'll take the tan of alpha, will be the opposite side, which is 1, over the adjacent side of root 3. So therefore, alpha will be the arctan of 1 over root 3. Alpha is equal to pi over 6. So if this angle is pi over 6, and we want the angle from the real axis, then theta will be pi over 2 plus the pi over 6. So you've got 3 pi over 6 plus 1 more, 4 pi over 6, or 2 pi over 3. So this will be our argument, and this will be the radius. So in modulus argument form, z will be 2 multiplied by the cos of 2 pi over 3 plus I sine of 2 pi over 3. Okay?